All right, so on example 8, we'd already started it, and we said they gave us the sine of alpha was 4/5, and for A, we found that cosine of alpha was equal to 3/5, right?
Yeah, negative 3/5.
Oh, negative 3/5, thank you. And then they told me sine of beta was 1/2, and we found cosine of beta was equal to...
Square root of 3/2.
All right, and I did that because we're going to need that for D, which is where we're at. So for D, they told us we're looking for sine of alpha plus beta. So we have an identity or formula that tells us that that is equal to sine of alpha cosine of beta.
Plus.
Good. Plus cosine of alpha sine of beta. And so we just need to plug in then for these trig functions. So sine of alpha, what is sine of alpha equal to? Good. Times, what's cosine of beta?
Square root of 3/2.
Good, that came from part B. Plus, what's cosine of alpha?
Negative 3/5.
Times, what's sine of beta?
How you know it's square root of 3/2?
1/2.
Because we found it in B. That's why I went back over what we got in A and B. C I didn't go back over because C is just like D. It was just where we had expanded it and then we plugged in. All right, so remember, how do we multiply fractions? So when I multiply these two, I get 4 square root of 3 on top over 10 on bottom. Plus, when I multiply these two, I get negative 3 over 10. Remember, add your numerators, since they already have that common denominator, okay? So we have 4 square root of 3. Uh-oh, I'm too low. Let me just do it to the side here. So we have 4 square root of 3. I have plus a negative. What's plus a negative? Minus 3 all over the common denominator of 10. And can I reduce that anymore? No, and the only way I could reduce this, guys, is if the 4, the 3 outside the radical, and the 10 were all divisible by some number other than 1. And since they're not, that is our solution.